Okay, so today we're going to talk about the fundamental theorem of algebra. So I'd like you to try this. So put me on pause and solve the equation, solve it for the zeros. Okay, so put me on pause and then come back. Okay, so I'm looking for the zeros, which means I have zeros equal to x squared plus 6x plus 45. Okay, so to solve this, I am going to subtract 45 from both sides. So I get x squared plus 6x is equal to negative 45. So I'm going to complete the square. So I'm going to do half of b. Half of 6 is 3. Squared is 9. Add it to both sides. So I get x squared plus 6x plus 9 is equal to negative 45 plus 9. And negative 45 plus 9 is negative 36. And then when I factor the left side, I get x plus 3 squared is equal to 36. And then I'm going to take the square root of both sides, and I get x plus 3 is equal to plus minus the square root of negative 36. So remember, a negative underneath the radical becomes an I. So it's x plus 3 is equal to plus minus 6i. So I'm just going to rewrite this over here. So x plus 3 is equal to plus minus 6i. I'm going to minus 3. X is equal to negative 3 plus minus 6i. All right, so these are my roots. My roots, or my zeros, are x equals negative 3 plus 6i, and x equals negative 3 minus 6i. Now, if I want to write these, I can actually write these as factors, what are called linear factors. So as linear factors, I would push everything over to the left with my x. So I would add 3 minus 6i. So it'd be x equals x plus 3 minus 6i. There's one factor. And times x plus 3 plus 6i. Those would be called my linear factors. Okay, so what we're going to do today is solve polynomial functions, so all different kinds and all different ways doing what we've been doing for the last few days. So when we're solving, you could use factoring. We're going to be solving using higher power factoring. You can use synthetic division to find your factors. You could also use long division. You can only use complete the square and quadratic formula when you have quadratics. That would be when you have an x squared. And then I want you to, after you get your zeros, I want you to write as linear factors. All right, so let's take a look at the first one. The first one's pretty basic. It says find the zeros and write as linear factors. So I have 0 is equal to x to the third plus 4x. So I notice there's a GCF, so I'm going to factor out the GCF. X times x squared plus 4. Okay, so notice this here, x squared plus 4, that is not the difference of two perfect squares because of the plus. But I do know this, that x is equal to 0, and x squared plus 4 equals 0. And what I could do is minus 4 and get x squared is equal to negative 4. Take the square root of both sides, and I get x is equal to plus minus, right? Don't forget the plus minus. And then the square root of negative 4 would be 2i. So these would be my zeros. My zeros would be x equals 0, x equals 2i, and x is equal to negative 2i. My linear factors would be x times x minus 2i by subtracting 2i from both sides, and x plus 2i by adding 2i to both sides. These are called my linear factors. Okay, so let's flip it over and we'll try one on the other side. Okay, so I have here f of x is equal to x to the fourth minus x squared minus 2, 20. So one of the other things I wanted to talk about is what kind of zeros you can possibly have. So I can possibly have 4 real zeros, 4 real. I could have either 2 real or 2 imaginary, or I could get 4 imaginary. Okay, and the reason why the imaginaries have to stay in groups of 2 because of think about the quadratic formula completing the square, you always have that plus minus in there. So if I have 2 real, if I have 2 imaginary here, well then what would be left for my real would be 2. So if I have 4 I can't have 3 imaginary. It has to be groups of 2. Okay, so I notice here that I have this higher power polynomial, and this is actually factorable. So this is 0 is equal to x to the 4th minus x squared minus 20. So I can multiply the first times the last, I get negative 20x to the 4th. So what multiplies to 20 minuses to a 1 would be 5 and 4. So it would be 5x squared and 4x squared. So it would be negative 5 and positive 4. Bring down the 20. Bring down the x to the 4th. Now we can factor by grouping. Okay, we group the first two. That should actually be around. So I have the GCF is x squared times x squared minus 5. GCF is positive 4 times x squared minus 5. So I have x squared plus 4 and x squared minus 5 equals 0. T-chart, set each one equal to 0. So I have x squared minus 5 equals 0. Add 5, x squared equals 5. Square root both sides, x is equal to plus minus the square root of 5. On to the other side, I have x squared plus 4 equals 0. Minus 4, x squared equals negative 4. Take the square root of both sides, I get x is equal to plus minus 2i. Okay, so now these are my zeros. Now I want my linear factors. So it'll be x minus 2i, x plus 2i, x plus the square root of 5, and x minus the square root of 5. These are my linear zeros. Okay, so let's take a look at number 3. So I have, my degree is 4, so that means I could have 4 real zeros. 4 real. Going to write this down. Let me move this all up actually. Okay, so I can have 4 real zeros. I can have 2 real, 2 imaginary, or I can have 4 imaginary. Okay, so now let's start solving this. So I notice I do have a GCF, and that GCF is 5. So I factor out the 5. So I have 5 times x to the 4th minus 49. And then this is the difference of 2 perfect squares, so I can factor that. So that's 5 times x squared plus 7, x squared minus 7. Remember, it still equals 0. All right, let's do our t-chart. This 5 over here is not going to do anything because there's no x. So I have x squared plus 7 equals 0. X squared minus 7 equals 0. All right, so in the middle here, minus 7, x squared equals negative 7. Square root both sides, so I get plus minus the square root of negative 7, which is plus minus I, the square root of 7. On the right side, x squared equals 7. So x is equal to plus minus the square root of 7. So these are my zeros. Zeros. And then I want my linear factors. So it'll be x plus I, the square root of 7. X minus I, the square root of 7. X plus the square root of 7. And x minus the square root of 7. And these are called your linear factors. Okay, so let's try the last one. All right, so I have f of x is equal to x to the 5th plus x to the 3rd plus 2x squared minus 12x plus 8. So let's write down, I could have 5 real. I could have 1 real, 4 imaginary. Remember, imaginary has to be in groups of 2. 3 real, and 2 imaginary. Okay, and I cannot have 5 imaginary. Remember, they have to be groups of 2. All right, so let's see here. I notice that I have an x to the 5th. So I'm going to have to try to find a 0. So let's do the rational zero test. So the real zeros. All right, so I want remember, it's the factors of the constant over the factors of the leading coefficient. But my leading coefficient is 1. All right, so my real zeros. So my factors of 8 are going to be plus minus 1, plus minus 2, plus minus 4, and plus minus 8. So let's try 1. Let's do f of 1 and plug it in and see if 1 is a 0. So I have 1 to the 5th plus 1 to the 3rd plus 2 times 1 squared minus 12 times 1 plus 8. So plug that in your calculator and you get 0, which means x equals 1 is a 0. So I can use right now synthetic division to start breaking this down. So I'm going to put 1 on the outside, and I have a 1, 1, 2. No, sorry, 1, 0, because I'm missing a term. So 1, 0, 1, 2, negative 12, and 8. All right, so I bring down the 1, I get 1. So now I have 1, 1. I still have 1, 2, 2, 4. 4 here is negative 8, and then negative 8, and I get 0, right? So, which makes sense because I'm saying I should get a remainder of 0 because I'm saying that x minus 1 is a factor. So x minus 1 is a factor. So I have then, here's my other factor then. Right, so x minus 1 is a factor, and then I have x to the 4th plus x cubed minus plus 2x squared plus 4x minus 8. There's another factor. I just have to move everything up. Okay, so now I have this polynomial here, and I have to try to get another 0 here. So let's see if f of negative 1 works. So let's plug in negative 1, and let's see if that's a factor. So it's negative 1 to the 5th plus negative 1 to the 3rd plus 2 times negative 1 minus 12 times negative 1 plus 8. So plug that in your calculator, and you actually get 20. So negative 1 is not a factor. Let's try negative 2. So f of negative 2. So it's negative 2 to the 5th plus negative 2 to the 3rd plus 2 times negative 2 squared. Put a square in there. Minus 12 times negative 2 plus 8. And you get 0, which means x equals negative 2 is a factor. Okay, so now I'm going to go from this polynomial. Okay, so I'm going to put negative 2 on the outside because that's one of my zeros. And I have 1, 1, 2, 4, negative 8. So I have 1, negative 2, negative 1, 2, 4, negative 8, negative 4, 8, and I get 0, which makes sense because it's my remainder is 0. So now I have this so far. So these are my factors. Have to start moving things up. All right, so I had that x minus 1 is a factor. Now I know that x plus 2 is a factor, and now I can write this as a factor here. So that's x, and I started off with an x to the 4th, so it would be x to the 3rd minus x squared plus 4x minus 4. Okay, so now I notice that inside my parentheses, I can actually group this. And factor out the GCF is x squared times x minus 1. GCF is 4 times x minus 1. So now I have all my factors, x minus 1, x plus 2, x squared plus 4, and x squared minus 1. Now to find my zeros, set them all equal to 0. We get x equals 1, x equals negative 2, x equals 1 down here. So I have 2 of the same roots. That means it was tangent there, right? So multiplicity is even. So I get x squared plus 4 equals 0. X squared equals negative 4. X is equal to plus minus 2i. So now what are my linear factors going to be? So my linear factors, so these are my zeros. And now my linear factors, x minus 1, x plus 2, x plus 2i, x minus 2i, and I had an x minus 1 again, which is x minus 1 squared. So this is my linear factors. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.